Hey, it's Mrs. Lawson. Welcome to the Chapter 2 review for the test. I won't be doing every question with you, but I will be doing a good amount of them with you. The expectation is that you do try some of these on your own. And if the full video is not on here today, Friday, this weekend, the rest of it will be up there by Monday, okay? So first, just answering the questions at the top. What does a quadratic function look like? A quadratic is this U shape. It's called a parabola. That's its parent function shape. A cubic in its parent function shape looks like this. And when I look at the equations of a, h, and k, what do they do? So in front of these parentheses, you might see a negative, and that's going to make it flip. But otherwise, the a is going to be a stretch if that a value is bigger than 1. So those points are going to stretch further away from each other, or they're going to compress, and those points are going to just be closer together. I didn't spell compress right. When you see the H, remember we always take the opposite, and that will tell us to go left or right, and then this number will tell us to go up or down. And as far as what value should we use when we graph x squared or x cubed, I'll put those down here. For x squared, for our x values, we use -2, -1, 0, 1, and 2. And for our y values, we square those x values and we get this. All right, when I do my x cubed values, again, for x, I'm going to use -2, -1, 0, 1, and 2. All right, I just had a little interruption, so I'm not quite sure I left off. I was talking about the x and y values. So finishing the y values for x cubed, they're going to be -8 because you're cubing -2, -1, 0, 1, and 8. So let's start with number 2, and then I'll get you started on number 1. So just identifying what's about to happen. This half means I'm going to compress it. These points will get closer together. This -3, I take the opposite and I'll go right 3, and this 5 means I will go up 5. So first thing I'm going to do is anything in front of those parentheses creates a new y value. So I'm going to take all of these y's and just cut them in half. So -8 is -4, -1 is -1/2, 0 is still 0, 1/2, and 4. And now that I have new y values, I don't need these old y values. So I'm going to go ahead and graph these. These half points are going to be a little tough to graph on here, so bear with me. But here is -2, -4. Here's the -1, -1/2, 0, 0, 1/2, and 2, 4. So now what I'm going to do is take these 5 points, and I'm going to move them all, each one, right 3 and up 5. So I'm going to start with this upper right point that you see, and I'm just going to count right 3 and up 5, and that will take me just a little bit off the graph, which is okay. The next point down from it, which is one of those half points, I will go right 3 and up 5. 1, 2, 3, 4, 5. I'll end up about there. 0, 0 is going to go right 3 and up 5. And the other half point is going to go right 3 up 5 and end up about there. And my last full point, the bottom left one, will go right 3. 1, 2, 3, and up 5. And so those green points are my new points. Now I'm going to connect them. And I'm ready. So first, where is this increasing? I do want to go through and mark my important points. So that's the endpoints. On this arrow, it's left and down. On the upper right arrow, it's going right and up. I want any turning points, which, we will talk about this point here later as 3, 5, but it's not going to be important for now. And any x-intercepts, which I can't tell what they are, so I'm going to leave it. All right, so increasing. This whole graph is increasing, and remember, we do use the x values when we do that, so it starts at -infinity and goes to infinity. If you don't want to write that, you can always write all real numbers. My y-intercept, we're going to do mathematically because I can't see that on the graph. Remember, all y-intercepts are when x is 0, so I'm just going to put 0 in for x. I'm going to follow my order of operations and get my y value. So first I start with parentheses. So I start with 0, take away 3, that's negative 3, and then I'm going to square it, and negative 3 squared is 9. So now I have half times 9 plus 5. Now I'll do my multiplying. Half of 9 is 4.5. And then I'm going to take and add my 5. So I just messed up somewhere, and I'm going to have to take a moment and see where I messed up. So give me a moment here. All right, so I saw the mistake. I wrote down my problem wrong. So I'm going to be doing a little erasing here. Hold on 1 second. This squared should be a cubed. So let's fix this. So I still start with my parentheses. 0 take away 3 is negative 3. And then I'm going to cube negative 3, which means negative 3 times negative 3 times negative 3. And that's going to give me negative 27. So now what I have is half times, I'll wrap it in parentheses, negative 27, and I'm going to add 5. So if I take half of 27, excuse me, that's going to give me negative 13.5. And then when I add 5 to that, and it would be nice to have a calculator, so negative 13.5, and then I add 5 will give me negative 8. Whoops. So will give me negative 8.5, which, you know, if I graph this a little bit better, is about right, you know, somewhere in this area is negative 8.5. And that is number 2. Boy, that seemed like it took forever. All right, number 1, we have only been graphing in vertex form. So what I'm going to have to do with problem number 1 is get it into vertex form. And I'm going to use this space down below to do that. So I will be putting my x's in their parentheses, and vertex form means I will be completing the square. So you can see by what I'm doing. I'm going to take negative 2, I'm going to cut it in half for negative 1. I'll square that and get 1. And 1 goes here, and 1 can go on the other blank because there's no number in front affecting it. So now what I'll do is take this negative 8 minus 8, take away 1 more, and I get minus 9 or negative 9. And then in parentheses, I'll have x. And again, with this squared out here, then this square tells me what goes in front. And then this is what I will be graphing. So when you're ready and you start looking at the changes, I'll write it up here now. This 1 means I will go right 1, and this 9 means I will go down 9. So I check to see if there's anything in those parentheses. Do I have to make a new y value? I do not. So at this point, you just need to graph these points because they're not going to stretch or compress or flip. And once you get those points, you may move them right 1 and down 9. And then I'm going to let you guys finish number 1. All right, let's move on to the next part. So going through these questions, this is going from one form to the other. This was on your quiz as well. And how do you switch from standard form to function form? This first question. So you'll see what my abbreviations mean up here. So to go from standard form to factored form, you will factor. So keep that in mind. To go from standard form to vertex form, that's where you need to complete the square. And, you know, that's where we take that number and we cut it in half, and then we square that value. How do you switch from factored form to standard form? Well, if you have factors and you have to get to basically standard form is no parentheses, this is the neighbors. And how do you switch from standard form to factored form? Oh, that was this. Look, this showed up twice. Didn't even realize. Same here. And when factoring, what's the first thing you should always look for? You should always look for a GCF. When factoring, how do you know when to make this x? That's because there will be 3 terms. And when factoring, how do you know when to use a difference of squares? And I'm going to create a problem below that would show that. First, there has to be subtraction for the division or difference part. And then the 2 terms that you have will need to have square roots. Perfect square roots. So this has a perfect square root of 5x, and this has one of 81. Another one I could have done is x squared minus 100, because I do have the subtraction, and then I've got the square root of this is x, and the square root of this is 100. All right, so going through this, starting with number 3, this is in standard form, and I will be going to factored form. So going up to that means I will be factoring. Again, the first thing I want to look for when I factor is there a GCF. I don't see one in this problem, and I will be factoring. I'm going to make the x because there are 3 terms. So here's my x, and I'll have negative 24x squared and 5x. So factors of negative 24 that get me to 5x are 8x, and then I'll want a 3x. If you're doing this the original way, I'll rewrite 5x instead of 1 term with 2 terms. So I'm doing that right now, rewriting the original problem, but again, 5x is split up into these 2 terms. And then you want to group your first 2 and your last 2. And I look for a GCF, so I'll factor out an x, and I'm left with x plus 8 in my parentheses. So when I factor the next set, I will have to have my matching set, and that means I factored out a negative 3, and so when I factor, I get x minus 3 and x plus 8. If you're wanting to do this new version of factoring, then you can go straight to your parentheses. And the first thing you're going to look at is what would you multiply to get to x squared, and that would be x and x. And then I make these 2 branches, and I want to now focus again here. I want to ask myself, for instance, I'm going to change to colors. X times what can give me 8x? So that's an 8. I can put plus 8. And then, sorry, I drew this branch wrong. X times what? X times what can give me negative 3, and that would be a negative 3x. I'm sorry, what x times what can give me negative 3x here, and that's a negative 3. And so I have my factor. So this is the final answer. All right, number 4 is the same type of problem. It's in standard form. I want to switch it to factored form. I'm going to factor. The first thing I'm going to do when I look here, is there a GCF? There is not. And since it's 3 terms, I'm going to make my x. So I need factors of 12x squared that get me to 7x, and that's going to be 3x and 4x. Again, if you're doing this the original way, 7x will be replaced with this version of 7x, so you can write it. And now what you can do is your grouping. On this one, I'm going to actually just try this newer method and go straight to my parentheses. So this will be my factors. So again, when I fill out the first term of each set of parentheses, it's what times what will give me this 2x squared, and only 2x and x will do that. So after that, I want to know 2x times what, and x times what can give me this. So when I go through this and I want to know 2x times what can get me, for instance, to this 3x, that doesn't work. But I can take this 2x times a 2 to get this 4x. And that means I'll have to take x times something to get this 3x that I'm circling, and that's 3. And those are your factors. So now it's in factored form. All right, next problem, I want to get into vertex form. So again, to get into vertex form, what I'm going to have to do is complete the square. And that's where you take the number, you cut it in half, etc., etc. So what I'll do is I will put my, whoops, I don't want that color, is I'm going to put this in parentheses with those blanks. And I can't complete the square until it's x squared, so I'm going to factor a 3 out. And now I take this number, 10, not 30. I cut it in half, that's 5. I square 5, and I get 25. But when I go to the next blank, I won't write 25 because this is really 3x squared, 30x. So even though I wrote 25 down, it's really worth 75, and that means I'll want to subtract 75. And so clean it up, I start here, 5 take away 75, that's negative 70 or minus 70. In my parentheses squared, I'll have x, and then it'll be plus, and again, I just look what's in front of the squared, and that's what goes here, and then hopefully I don't forget about that 3. So that problem is now in factored form.